Mr. Hansen. We're continuing our series on one variable statistics, and today I'd like to start by having you look at these names. They should say something to you when you look at them. Tiger Woods, Michael Jordan, J.K. Rowling, Bill Gates, Amadeus Mozart, Adolf Hitler. And I put Adolf Hitler there just so that you realize it's not just people who were wonderful, but there's something else they all have in common. So what is that thing they have in common? And if you said that they were kind of the very best, or they stood out among the crowd in things, in terms of the things that they did. So Tiger Woods, lowest golf scores, and if you compare him to most of your PGA golf players, he probably has quite a bit lower than most of them. Michael Jordan, most points. And I know some people would rather I put LeBron James there, but I'm trying to deal with figures from the past. They can't be historical until they've passed on from their time. J.K. Rowling. J.K. Rowling is an author, and I would believe books sold, in terms of books sold, she did the Harry Potter series. She just far and away, she just blows away the competition. Bill Gates, I'm going to say money on this one. Also computer stuff, but he's far richer than most all of us ever will be. Amadeus Mozart, he has composed more songs, and not just composed, but songs that people still listen to. People listen to more of his songs than probably any other musician in the world, and maybe that's arguable, but I know he's up there at the top. And then Adolf Hitler, he's probably responsible for more deaths than almost anyone else who has ever lived. And some historians might argue with me, but he's at least at the very top of his game in terms of that, which is a negative thing, not to put that in a positive light or anything. Okay, so there we have it. These people all stood out. We would call them outliers because they're far and away different, more or less, than the rest of the crowd. So that's what an outlier is, but it's kind of a very vague term. When does one become an outlier? How far away from the cluster of other data points do you have to be an outlier? So that's kind of what I want to talk about with you today. So here, length of an English paper in pages. When I was in college, there was a teacher who had us write our biography. And it was interesting. It was an interesting assignment because she didn't give a page limit on it. And I thought she was a glutton for punishment because I knew there are people who would write lots and lots of pages about themselves. I'm not that way. Mine was actually quite short. I like being concise and not putting more work in than I have to. But some people got carried away. So at what point would you consider yourself an outlier if you were in this class? So take a look at the data we've got up here. We've got 1-pagers, 2-pagers, 3-pagers, 4-pagers. I'd probably be kind of in that in there, and then it kind of settles down a little bit. A 9-pager, 2 10s, an 11, a 12, a 20, and a 28. So which of these points on this right end are going to be outliers? So that's kind of the question. And let's take a look at this data. I have it written in raw data form. The dot plot helps us kind of see that there's a skew to it, and these are possible outliers for sure. 20 and then 28 and maybe even 12 and 11, who knows. But let's kind of see where we draw the line in terms of outliers. So here's the raw data. There's 27 pieces of data there, and we're going to do a 5-number summary so we can build a box plot. So the minimum is 1, the median, we need quartile. Sorry, let's just give myself a little bit of room here. Quartile 1, and then the median, quartile 3, and then the maximum. So the minimum and the maximum are really easy. You got 1 and you've got 28. And the median, if you take 27 pieces of data and add 1 to that, that's 28 divided by 2 is 14. So we're going to count in 14 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's this 5 right here. 50% of the data is to the left of that 5. 50% of the data is to the right of that 5. Now we've got to the left of that 5, we don't include the 5, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 pieces of data. Add 1, remember that n plus 1 over 2 rule. So 14 divided by 2 is 7. 1, 2, 3, 4, 5, 6, 7. It's that 3 right there. And 1, 2, 3, 4, 5, 6, 7. We've got that 9 right there. Okay, so we've got a 3, we've got a 9. So now we're going to build a, oh, by the way, this breaks up into 4 equal groups. There's 25% of your data, 25% of your data, 25% of your data, and 25% of your data. Let's make a box plot to kind of show what that looks like. So I'm going to just 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. So we've got 1 here, 1 right there, and we've got 3 right there, and we've got 5 right there, and we've got 9 right there, and we've got 28 right there. So you can definitely see it's skewed. And now we can start thinking about outliers. There's a way of doing this that all mathematicians have agreed on. It's a bit arbitrary, but they've come to this agreement. And the way to decide if something in a data set is an outlier is to take Q1 and Q3, so and subtract those. You get the IQR, that's 6. So the IQR is 6, the interquartile range. That's the length of this box, 6 units. Okay. So all we have to do is we have to times 6 by 1.5. So we want 1.5 of those boxes. So it's IQR times 1.5 plus Q3. So 6 times 1.5, that's 9. Now we're going to take 9 and we're just going to tack it on to the top end of the box. So 10 plus 9, we're over here at 19, right there, 19. And we're going to call this a fence. It's a fence, it's an upper fence. Okay, so that's, now in other data sets you might have to worry about outliers on the lower end. This time you won't have to, but the way you find the lower fence is you go IQR times 1.5, and you go Q1 minus the IQR times 1.5. So Q1 is right here at 1, and then we would subtract the 9 from 1, you get negative 8. So it's kind of way over here. We don't have to worry about that because no data is in negative numbers for this data set. Okay, but let's take a look at this upper fence. If you are above the fence, if you're on the fence, you're still in the regular data, but if you are above the fence or below the fence, you have become an outlier. So let's go back to our data here. We have 20 and we have 28, and our fence was at 19. So that 20 is an actual outlier, and so is that 28. And we know that 12 is definitely not an outlier. So that's kind of how you determine if something is an outlier in a data set. So what do you do once you've determined you have an outlier? Okay. For the purposes of data analysis, you may want to consider removing these from your data set. But if you do remove them, it's important that you explain why. Maybe it's a documentation error. Maybe that was supposed to be instead of 28, maybe that was just supposed to be 8 and someone accidentally typed in a 2. Or maybe that person is just far and away writes tons and tons more than other people, and you don't want them included in the data because it just skews your data too much. So you have to have a reason for pulling outliers out of the data, and you have to give that reason in any kind of a research paper that you would do. And then finally, with outliers, the last thing that you probably need to know is that once you've taken out your outliers, if you have a box plot, the box plot changes just a little bit. And this is how it might look. In computer programs, GeoGebra and other programs, would go something like this, and then they'd have a little star here and a little star there, and the new maximum would be 12. And so that's the altered box plot. It's saying, okay, this is really how most of the data looks. This star at 19, or this star at 20, and this star at 28 are outliers. And there's a way to kind of make that happen in computer programs that do statistics. So that's kind of the big idea. Hope this has been a little bit helpful to you. Hope you're understanding what outliers are, how you deal with them, and how you determine if a piece of data is even an outlier anyway. This is Mr. Hansen signing out. Thank you and have a good day.